Hi, welcome to this video on empirical formula. Now, we've already seen before molecular formulas. So we might have a molecular formula, so C3H6. Now the empirical formula is based off the molecular formula, but it's the simplest ratio in which we can express these atoms. So here we've got C3H6. Now we can divide each of those by 3 to get down to CH2. And the empirical formula will be the simplest expression of this molecule. So we could divide each by 3, so we did, to get down to CH2. I have a molecule like C6H6, so this will be its molecular formula. Its empirical here will be CH, because we're going to divide each one by 6, and we've got there the simplest expression of its atoms. We can also go a bit bigger than this. So here C3H6O2 could be expressed, C4H8O2 could be expressed simpler as C2H4O. Because we can simplify that down, we could divide each one by 2 to get to a simpler expression. Sometimes though, as we just saw in the example I drew there, C3H6O2, that can't be simplified any more than it already is, in which case its empirical formula is identical to its molecular formula. Now we work out empirical formulas from percentage compositions. So in our analysis, we might be able to see that a compound is 32.4% sodium, 22.5% sulfur, and 45.1% oxygen. From these numbers, we can then work out what the empirical formula is. And we do that in a few steps. The easiest way is to create a table. I'm going to create sodium, sulfur, oxygen. Put percentage composition first of all. So sodium, you can see up there is 32.4, sulfur is 22.5, and oxygen is 45.1. And the first step is to divide by that AR. Now AR stands for atomic mass. So sodium's got its own atomic mass, it's 23, sulfur 32.1, oxygen 16. We can see these on the periodic table. So each individual one of these will be divided by its own atomic mass. So sodium 32.4 divided by 23 gives me 1.409. Now I'm going to 3 decimal places here, and it's always helpful with these to go to as many decimal places as possible. 3 is probably the best number, the one I like to stick with. 2 can sometimes lead you down, get you into trouble. 1 is best avoided. So 3, kind of the ideal number. Sulfur 22.5 divided by 32.1 will give me 0.701. Oxygen is 45.1. Its atomic mass is 16. So it will give me 2.819. All of those atomic masses, they're the relative atomic masses we find on the periodic table. Once we got to this next stage now, what we're going to do is we're going to divide them all by the smallest answer. So each one of these is going to get divided by the smallest, and I can see the smallest is this sulfur here. So I'm going to divide sodium by 0.701, 0.701 by 0.701, and 2.819 by 0.701. So if I do that, I get my sodium at 2.010, my sulfur exactly 1, my oxygen at 4.021. Now what we can see is a number very, very close to 2. So close, I am just going to call this 2. I can ignore this now. I can round down when it's that close. Sulfur I've got at 1, and this oxygen, again, I can round down, it's so close. I can now see the empirical formula. I'm going to have 2 sodiums, I'm going to have 1 sulfur, and I'm going to have 4 oxygens. And that's the empirical formula for this compound that we got these percentages for. Try another one of those. So similar type problem, same compounds, different percentages now. So I'll have sodium, sulfur, oxygen. I'll put their percentages down first of all. So I've got 29.1% sodium, 40.5% sulfur, and 30.4% oxygen. My first step is going to divide again by their atomic masses. So sodium divided by 23 will be 1.265. Sulfur divided by 32.1 will be 1.262. So you've got 2 very similar numbers there. And oxygen, 30.4 divided by 16 is going to give me exactly 1.9. So just to keep the pattern, show I'm going to 3 decimal places each time, put 2 zeros in, even though it's a bit redundant. So the next step is to divide each of them by the smallest. Make sure I spell smallest right. So once again, my sulfur's just my smallest. So my sodium divided by 1.262 is going to be so close to 1. I'm just going to call it 1. I'm going to round that down. That's definitely going to be 1. And this is going to be 1.5, which presents a bit of a problem because the sodium sulfur is fine, but the oxygen, you can't have 1.5 of an atom. So this can't happen. So what we're going to do here this time, it's too far away for me to round up or down. This was 1.506. So I can't say, it's just 1 or it's just 2. It's too far away. Instead, what I have to do this time is get this to a whole number. I have to double it. But that'll also mean I'll have to double this one and I'll have to double that one. And the empirical formula of this is Na2 S2O3. So that's now a whole number. So that works. And these are up. We've just doubled each of them. Final one we're going to look at. We're going to add a bit of extra info to. And this time we've got our percentages and our compositions, and we've got also a molecular mass. Now this MR, the molecular mass, is the molecular mass of the molecular formula, not the empirical. And that's important to keep in note for later on. So if we go for nitrogen, I've got hydrogen, I've got sulfur, I've got oxygen, I've got 12.28% nitrogen, 3.51% hydrogen, 28.07 sulfur, and 56.14% oxygen. Now, first step, divide by the atomic masses, which you see on the periodic table. Nitrogen is 14, so 12.28 divided by 14 will give me 0.877. Hydrogen will be 3.51. Sulfur, 28.07 divided by 32.1 gives me 0.874. Got 2 very similar numbers again there. And oxygen is going to give me 3.509. Sorry, that was a 0 there. I'm just going to put it in to show I'm going to 3 decimal places. So I've got my numbers there. My next step is to divide by the smallest, which is 0.874. I'm going to round this one down to 1. I'm going to round that. It was 4.016. So I'm just going to round that. It's close enough for me to round to 4. That's a 1. And that's very similar to the hydrogen. 4.015. I'm going to round that down because it's so close to 4. And that creates my empirical formula. what I can do is I can see, does this empirical formula have the same mass as the molecular formula? And nitrogen is 14, hydrogen is going to be 1, but I've got 4 of them. Sulfur is 32.1, and oxygen is 16, but I've got 4 of them. If I add all those together, I get 114.1. Now I can see then that this empirical formula's mass doesn't match the molecular formula. If we saw over here when we looked at the start, that's in here, this will be 14. This over here is 42. See, they don't match. But 42 divided by 14 is 3. And this is 3 times each of the atoms in here, which is what we can look at now with this molecular formula. If we take 228.2 and divide it by this empirical formula mass, we get 2. So what I'm going to do to work out the molecular formula from the empirical is I'm going to times everything by 2, which will give me N2, H8, S2, O8. So that's my molecular formula. My empirical is just NH4, SO4. So we can work out, if we have the molecular mass of the compound, we can work out the empirical formula and the molecular formula. And that is empirical formula calculations.